Today's lesson is called, What Happens If I'm Wrong? Wah, wah. Also known as the Goldilocks Conundrum. And for those of you that don't know, a conundrum is a very difficult problem that seems to go round and round and round. The Goldilocks Conundrum. Go ahead and split your paper into two halves and make yourself a T-table. Label one side partial quotients and the other side traditional algorithm. If we were to solve the following problem, 458 divided by 7, we could do that in partial quotients, and we might solve it the following way. Go ahead and copy this down. 65 remainder 3. There would be a lot of different ways of solving this problem. What I'd like you to notice is right here. Goldilocks could have taken out more than 50 groups of 7. She could have taken out 60 groups of 7 to get 420. We can see eventually she got the 60 because she did another 10 right here. And really right here she could have taken out more than 10 because she had to keep on taking out more groups. Now, here's the problem. When you work with traditional algorithm, Goldilocks might run into a problem if she used 50 as her first step. Check it out. Poor Goldilocks. If Goldilocks found the fact 5 times 7 is 35 and thought to herself, well, that's pretty close to 45 and it's less than it, so that's good, it didn't go over, she would then multiply 5 times 7 is 35. She would then subtract and she'd have 10. Uh-oh. Just like Goldilocks as she was trying out the chairs. Some were too big, some were too little, some was just right. The soup was too hot, too cold. We're looking for the Goldilocks one, the just right number. This is not the just right number. It's too little. She could have taken out another group of 7. Look what happens if she tries to continue on. Well, we've got a 10 right here, so then I could take out one more group of 7. Where does that go? Right there, and then 7 times 1 is 7, subtract is 3, bring down the 8, and another group of 5 7s would be 35, remainder 3, 515, remainder 3. What? That's not even close. Something has gone very wrong, and where she went wrong was right here. She could have taken out more groups of 7 than just 5. And we know by looking at how many were left when we subtracted. 10 is greater than 7. So with the traditional algorithm, you have to get it just right. Okay, so if we know we need to take out more groups, what happens if Goldilocks overshot and tried to take out too many groups? Let's see what that looks like. I don't have any more room on my board, but what I want you to do is just skip a couple of lines and write this right underneath this problem, still in the traditional algorithm category. Let's say Goldilocks was using the traditional algorithm and she overshot her budget. She guessed something too big. Maybe she found a fact that was close to 45 and found 7. Multiplied. 7 times 7 is 49. But then she goes to subtract. The answer is not 4. We're taking 49 away from 45. We can't do that. It would be like a -4. So whereas the last guess was too small, this guess was too big, and it doesn't work either. We have to find the just right fact, or we can't use the traditional algorithm. So, by now you've probably figured out that if 5 was too little and 7 was too big, 6 should be just right. Let's try it. Again, you go ahead and write down the just right fact right underneath. Ooh, and while I'm thinking about it, let's label this too big. Go back and label your first example too little. And we can label this one just right. The just right fact that we could find would be 6, because then when we go to multiply, 6 times 7 is 42. And when we subtract, first of all, we're able to subtract without going into negative land. And when we subtract, 3 is less than 7, which means we could not have taken any more groups of 7 out. We couldn't have taken 7 groups out because there are only 3 left, not 7. So now we can continue with our problem. We can bring down the 8. We know that our just right fact will be 5 because 5 times 7 is 35. And we subtract, and we won't get a number that's greater than our divisor, than 7, which means we can't take out any more groups of 7. We have 65 with 3 as the remainder, just like we did with partial quotients. The big difference here, though, is that with partial quotients, you can lowball it and do a fact that is lower than what you could have done, and then just keep going until you finish. Whereas with the traditional algorithm, every digit in the quotient has to be that just right digit. Otherwise, you run into problems of shoulda, woulda, coulda, taken more groups out, and you get a really funky long answer with too many digits in it. Or you take too many groups out and you're in negative land. Too little, too big doesn't work. Each digit in the quotient has to be just right. And that's a lesson from Goldilocks and the 3 Guesses. No bears, students, blonde or otherwise, or dividends were harmed during the making of this video.